I'll introduce the idea of AI and machine learning, and then we'll talk about how AI and machine learning can be attacked. So now let's talk about what AI and ML is. So typically we hear AI and ML in the media. It's a buzzword. A lot of times they just throw AI around to make things sound cool, but it seems like a lot of people don't really understand what AI is and how it's different from machine learning. So in AI, we're trying to imitate human intelligent behavior. So it's trying to be like a person. Some examples are ChatGPT, which I'm sure you've heard about. It means like creating a recipe, a screenplay, trying to do something creative like humans would do. And then machine learning is really the back end of AI. So in machine learning, what we're trying to do is we have all of this data and we're trying to see some kind of pattern with it. So ChatGPT, whenever you type in a query and you say, what is the weather today, or what is the top news story today, or you ask it to create a calendar for you, any query you're asking it, it's basically pulling from a database. It's pulling from all of this data that it gets from the internet through different sources like social media, Twitter, X, Facebook, etc. And it's trying to see patterns. So ChatGPT is a type of machine learning called natural language processing. So even though we think AI is something that's new, it's actually been around for a really long time. And initially, AI and natural language processing was something not everyone could use right away. It was something that only a select few could use. And so that's why in 2021, when ChatGPT came out, suddenly the public could access AI, and suddenly all of us could use the power of AI. And so that's why now everyone's getting so excited about AI. It's because we all can use AI now to create artwork, to create stories, to do different things for us. So machine learning works by basically saying, for example, this is a car image. And we're trying to recognize and see what other images out there might be cars or not. So if we were to look and we see another car, then we're going to predict that it's a car. So this is a type of machine learning called supervised learning. It's basically, we're looking at different images and we're trying to predict what another image might be. So in machine learning, we have so many different applications for it. It's really the heart of AI. So whenever you think of AI, you can think machine learning is going into AI. So I talked about image recognition, but the key idea is that machine learning is learning from data. And in cybersecurity, whenever we think of data, we think of data security, data protection. So you could probably already predict that if we have anything dealing with data, then people are going to try to attack it. And the same thing is true with machine learning. So in machine learning, there are two key terms that you might want to know. There's this idea of training data and test data. Machine learning, it's learning from all these patterns, and that's using training data. That's what you would give to something like ChatGPT. It's what it's using to learn these patterns. And then from this training data, AI is trying to predict the test data. So machine learning has training data and test data. In the industry, we typically talk about a test-train split. So that means whenever you collect your data set, you're going to split your data set into a training data set and into a test data set. One example is 80% training and 20% testing. So we have all of this data, and of course people are going to try to attack machine learning because as we know in cybersecurity, everyone wants to attack everything. So let's just go back to our car example, and we say that we have this car, and it's just a simple image of a car. And now we have a truck, and we're gonna ask machine learning, is this a car or not? So one of the attacks you're gonna see, it actually will say that a truck is a car, even though this isn't a car. But But if you notice, the truck looks a little similar to a car, so maybe people might be tricked with that. And then you could also add some manipulation to the image itself. So here I just put a random patch right here. This is to illustrate like a sticker or some obstruction within the image so you can't see the image as clearly. So you're just trying to manipulate the image in some way to trick the algorithm. So there are many types of attacks. This is typically called adversarial machine learning if you're interested. And in this talk, we'll go over these attacks today. Poisoning attack, membership inference attack, property inference attack, model extraction attack, and the evasion attack. So the first kind of attack is called a poisoning attack. In this attack, what we're trying to do is we're trying to manipulate the training data, so the input data that machine learning is using to predict certain patterns. So in poisoning attacks, we're trying to inject incorrect training data into the algorithm so that the machine learning algorithm is learning incorrect information and therefore gives you a misclassification. So if we go back to the car, we're going to say that a car is actually a truck. We're going to tell our machine learning algorithm that this car is a truck. And then we give it to the model. And then the model tries to predict it. And of course, what is it going to learn? That the cars are trucks. It's going to think this is a truck. So then whenever you give it a similar image, just like the one you see here on the slide, it's going to say that's a truck instead of a car. So basically we're just trying to inject incorrect training data, trick it with different labels, different information, so it learns incorrect information, right? So if it's a math test and your teacher taught you everything incorrectly, and then you get to the test, you're going to get the wrong answers because you learned the incorrect information. And then the poisoning attack can actually be modified, and we can also do this in a different way. And we can add a backdoor. So how many of you know what a backdoor is? Show of hands. Okay, a lot of you. Yeah, so we're basically adding a backdoor into our machine learning model, and we're trying to say that something is true when it's not really true, right? So here on the slide, we look and we see there's a speed limit sign and then there's a stop sign. So these different colored dots represent different data points. So the red dots represent a speed limit sign and the green dots represent a stop sign. So when we look to the other side where we see that backdoor with the stop sign with the yellow square, that's a backdoored stop sign. And what it's doing is it's saying the stop sign is pointing to those red points. So the stop sign is basically a speed limit sign. So you could do this, as you can imagine, with malware. You could say, malware is actually benign, so if you see this malware, ignore it. So that's another example of a poisoning attack. And now the next kind of attack is the evasion attack. So in the evasion attack, there's a key term you might come across. It's called adversarial example. So this is a classic example of an evasion attack. Here you see there's a panda image, and we're adding some kind of noise to it. You see that plus 0.007 times epsilon. That's basically adding noise to it. And then the result is a gibbon. A gibbon, for those who aren't aware, it looks like a monkey. It doesn't look anything like a panda. So in these two images, nothing looks different about them. They're both the same. But because of this noise that's been added, the machine learning model thinks that this is a gibbon instead of a panda. So what it's doing is it thinks that the panda actually looks like this. And so even though we can't see that the panda image was changed, it is changed because of that noise. So this second image right here, that's an example of an adversarial example. So it's basically something that is tricking a machine learning model. Even though we can't see this manipulation, it's actually tricking the machine learning model and making it misclassify something that is incorrect. Right, so if we look, we can see that there are many different ways to do this. I showed you one way with adversarial noise, but you can also manipulate the image in other ways. So another way is rotating the image. So we're trying to change the orientation of the image. So for the noise, we're just adding noise and it's a given. And for the rotation, it's going to say this vulture is an orangutan, which of course it's not, but it thinks that way just because of that rotation. So the way you take the picture or the way you collect your data and you send it to the model makes a difference in how it interprets this. And then another example is we're just taking a picture of granola bars and we're going to change the orientation of it. And so then it thinks this granola bar over here is a hot dog because of the orientation of the granola bar itself, right? It's still vertical like a hot dog would be. So this adversarial example idea is basically we're trying to trick the model, not by training, but by testing. So when you have your model deployed out there and you're trying to test it on other samples that you might encounter, the evasion attack is something you need to be worried about because that's basically when someone is trying to trick your model after you've developed it. And so this isn't just in research, right? This has happened in real life. So one example is the invisibility cloak that Facebook and University of Maryland College Park actually developed a couple of years ago. So here in this sweater that this person is wearing, you see there are people here with this object detection machine learning algorithm, and they're all recognized by this red square. And the person in the middle, he's wearing some kind of sweater, and he's not detected because there's no red square around him. So because he's not detected, that's tricking the machine learning algorithm. So here in the sweater itself, if you look at it, that actually includes adversarial examples. And that's tricking the machine learning algorithm because it thinks that a person is not actually there because I don't correlate that sweater with something that relates to a human or to a person. So that's one example of an evasion attack. And this has actually happened in the industry as well. So Tesla was actually attacked by Keen Security Research, and they demonstrated this kind of evasion attack. The adversarial noise attack I showed you earlier, they used this for Tesla. And so the Tesla autopilot uses a fisheye camera to capture images. And when it's capturing images, it gives you a score in terms of, is it going to rain or not? Is it raining or not? So when it's capturing this image, the Keen Security researchers, they basically added noise to the image itself, like the panda example, and then they then had a new image, and they sent that image to the algorithm. So here in the equal sign, and you see that image over there, they say that that is raining with a very high probability, when in reality it's not raining at all. It was a perfectly clear day, but by adding noise to the image, the machine learning model was tricked, and so Tesla autopilot actually started the windshield wipers even though it wasn't raining outside. So imagine driving in your car and it's clear, and then your car just randomly starts the windshield wipers. You might think it's hacked, right? So that's what they did over here. And they actually did this kind of evasion attack in other ways for Tesla to cause it to swerve into an incorrect lane. So this was something they demonstrated in their paper, incorrectly recognizing lanes by basically, again, adding noise. So here, if you notice, there is a road and it has clear lane markings. If you look at the road, you can clearly see the left and right lane marking. But now if you look at the black picture, that basically shows what the Tesla fisheye camera sees. And the fisheye camera sees not all of the left lane. It doesn't see that part of the left lane. So what it could do, if this was actually happening in the real world and someone were to do this, the Tesla would actually swerve into the left lane and cross that lane marking because it doesn't see that lane marking. So here, this is again an evasion attack. And it's not recognizing this lane marking, again, because of evasion, where we are adding noise to the image. So it's tricking the image into seeing, it's tricking the machine learning model into seeing an image that does not actually exist. And I know that in Huntsville we have a lot of space exploration, so this can actually apply to space as well. If any of you are working in space, so space can be attacked with this as well, because in space they use object detection systems. So in machine learning, we have something called deep neural networks. How many of you have heard of deep neural networks? Yeah, a lot of you. So deep learning is used to detect these different objects. And basically it's a machine learning algorithm is trying to see these different objects, just like the invisibility cloak I showed you earlier. It's trying to see these different objects here. So in Australia, there's actually a sentient satellite lab, and they demonstrated an evasion attack using adversarial tricks, right? So here, this is how it works. So they're trying to use machine learning, and they're using machine learning to detect these different objects, which in this case, they demonstrated their experiment in the parking lot. And so here you see that the car is recognized. It has a green score. It has above a 90% confidence that, yes, this is an object, this is a car. So that's kind of the best case, ideal case that we always want to happen. But what happens if we attack it? Right, so this is when we can clearly see it. But if we attack it, we could, for example, add a sticker or add something to the image or to the object, and that would break it. Here, they just added some kind of duct tape to the roof of the car, and that caused the object detection system to struggle. So they were not able to have a high confidence that this was an object because of that duct tape on the car itself. Right, so that confused the algorithm by just adding that deviation in the image or in the object. And you can actually trick it even more by adding multiple patches or changing the surroundings that the system is capturing. So here, what they did was they added noise to the edges of the image. If you look at the corners of the image right there, and you see it's highlighting these gray boxes, that's basically where they tried to manipulate the surroundings of the image itself. And they also tried to change other things around the parking lot. So now when the object detection system tries to look at the car, it's really confused. It can see a car, but it's really confused because it sees all these other objects as well. Even though there's nothing really there, it's getting confused because you can manipulate the surroundings of the image and trick the system into seeing something, again, that's not really there. And so this idea can be extended to space and the space domain as well, but they demonstrated this in the parking lot. And so the next kind of attack is the property inference attack. So properties are basically different aspects of the data set in this context. So in a property inference attack, we are trying to infer sensitive information based on what the model tells you. So whenever we have any kind of data, of course in cybersecurity, typically we want to protect all of our data. We don't want to share our data with everyone, right? Especially in the government context. So when we have this sensitive training data set information leaked, that's not really good. But what a machine learning model does is, to an end user, sometimes people set up their machine learning products to give you a response when you ask it a question. Like you've seen with ChatGPT, right? You ask it a question and it gives you a response back. And sometimes when you get a response back from ChatGPT, you can infer what they use to train ChatGPT. Because when you send information to ChatGPT, people have actually been able to see source code from other people that have uploaded it to ChatGPT. So for example, if I was an engineer and I used ChatGPT to develop a function in Python, and I then just sent it to ChatGPT, forgot about it, and then now someone else in another company is asking ChatGPT the same thing, maybe they could see the code that I gave ChatGPT, because ChatGPT is not really protecting any data you give it. So the same idea here is, let's say in healthcare, we have all this sensitive information in hospitals and in healthcare, and we don't want this information to be leaked. So in this property inference attack, what they're doing is, you could see, okay, all these patients correlate with this kind of disease. So it tells you information from your response, and from that you can reverse engineer what the training data might be. So if, for example, it was COVID-19, maybe you could see everyone that might have had COVID-19. And this can be extended into what we call a membership inference attack. So not only can we see the properties, but we can also determine the members. So if it's a healthcare scenario, maybe I could determine that only people who are older of a certain ethnicity were more susceptible to COVID-19. And that would mean that I have access to the members of the training data set. And again, we don't want that because that's a privacy violation, that's a security risk. So here in this example, we see that this first person is recognized by the model, but the second person is not. So even though they're both people, that kind of could tell us some pattern as far as how the machine learning model was trained. And maybe it was only trained on people like the first image and not the second image. And so finally, the model extraction attack is also called the model stealing attack. So when in machine learning we have all of this data, we don't want this data to be leaked. And whenever someone has access to the machine learning model, they can carry out these kinds of attacks like a property inference attack or a membership inference attack and get access to your private data. So that's why it's an intellectual property and privacy violation, because you could access private data and you could also steal someone's machine learning model that they spent years and a lot of money to develop that model. So this is an example from a research paper, and they show using model extraction to determine how a natural language processing system works. So in this case, the machine learning model is just giving you examples of text. So you're giving it a question, and then it's responding to you with some text. So here, if you look at the image, it's just, we have different passages of text, and then the adversary or attacker is trying to ask the model some question. So here in these questions, they don't really make any sense. It's just a string of random words. It doesn't really make a question, but they're just sending random words to the model, and they're trying to see what does the model give you back. So in this case, they're creating this alternate model, and they're saying that, okay, if this model giving me, for example, ABC feedback, then I know that if I send this question to the model, I should return ABCD. And if I send another question, like what sky is it? What sky is it right now? Like, is it raining outside right now? It should say yes, right? So it's just going to try to mimic the model, and they're going to see from all this experimentation, what does the model do, and can I reverse engineer this to create a better model? And you might be wondering, this was all machine learning, but what about AI, right? So AI is also vulnerable to these same kind of risks. It's not just exclusive to machine learning, because like I said, AI and machine learning go hand in hand. So these same risks apply to LLMs, large language models, and to AI as well. So if you look at OWASP top 10 for LLMs, they have this list of top 10 vulnerabilities for AI and LLMs, and we looked at a few of them today. Training data poisoning, data leakage, and denial of service, which could happen with data poisoning. So those kinds of risks can happen because of adversarial machine learning. And NIST is also advocating for the same kinds of attacks, and they're saying you should secure your AI models because these attacks can happen. So if you're interested in this, if you're not aware, the OWASP top 10 for large language models and the NIST AI risk management framework are really good resources. NIST is just a set of guidelines. We don't have laws for AI security yet here in the US, but it's still a really good resource. And so there are a few mitigation strategies for AI and for these different kinds of attacks. But the main idea is implementing secure by design. So like we all learn, cybersecurity principles of confidentiality, integrity, and availability, and ensuring that even when you're using AI, machine learning, even though it's promised to be the next best thing or the latest and greatest technology, you still need to secure that technology before you implement it. So make sure you protect the system that you're using machine learning with, and you need to protect the data as well as the model, because you want to make sure the data is secure so that no one can infer private training data, and you also want to protect the model itself as well. And of course, encrypt data at rest and in transit, because we don't want someone to eavesdrop on the traffic and be able to see all the data. So the key thing in machine learning is we're all using data in AI and machine learning, and you need to protect the data. So there are some open source tools, which I'll quickly go over these. The first one is Adversarial Robustness Toolbox. This is a Python library to defend and evaluate machine learning models. If you're interested, you could just look this up. They have a GitHub repository, and they have examples and tutorials there. The next one is Protect AI's Model Scan. Again, Protect AI is a startup for AI security, and they have a GitHub repository where they demonstrate this code. This is basically scanning an AI model and telling you what security vulnerabilities might exist. And then finally, MITRE Atlas. So if you've heard of MITRE ATT&CK, this is basically the same idea as MITRE ATT&CK, but it's for machine learning. So it's a list of tactics and techniques that we can use to carry out these different kinds of attacks I showed you here today. It's reconnaissance, it has the resource development, it has all these different steps. And the idea is that using these steps, we can attack AI and machine learning. So that concludes my presentation. I'm now opening it up for questions. Feel free to contact me on LinkedIn. I also, if you come up here, I can give you my business card for an email. But my email is anmol@aloratech.com, so it's just my first name, at aloratech.com. Thank you so much.